A mysterious object from another star system just flew through our solar system and left behind more questions than answers. Now, in 2025, powerful new analysis techniques have revealed interesting new data about this visitor. Now, Michio Kaku warns us. The truth about Oumuamua might be far more disturbing than anyone expected. In 2017, astronomers detected something unprecedented. A cigar-shaped object speeding through our solar system on a hyperbolic trajectory. They named it Oumuamua, Hawaiian, for a messenger from afar, arriving first. But what made scientists truly uncomfortable wasn't just its bizarre appearance. It showed no ice, no heat signature, and no comet tail, even as it passed near our sun. And then, inexplicably, it sped up without any visible fuel or propulsion system. Theoretical physicist Michio Kaku and a growing number of leading scientists are examining this fresh evidence and reaching a startling conclusion. What we witnessed might not have been a natural object at all, but something far more unsettling. Advanced technology from beyond our solar system, too precise to be natural. What truly shocked astronomers wasn't just that Oumuamua entered our solar system. It was what happened next. As it passed by the sun, it accelerated, not in a random, chaotic way, but with a precise, controlled trajectory that defied explanation. When astronomers first saw the acceleration, they thought it must be outgassing, like a comet ejecting material. But there was absolutely no visible ejection of mass. Nothing, not even a wisp of vapor. Michio Kaku and his research team found groundbreaking new data after re-examining Oumuamua's trajectory using quantum-enhanced optical modeling. This wasn't just a refinement of old observations, it was an entirely new analysis method that revealed something astonishing. The new data specifically shows that Oumuamua's acceleration wasn't random at all. It followed a mathematical pattern that precisely counterbalanced its tumbling rotation. For every 7.3-hour rotation cycle, the acceleration vector adjusted by exactly the right amount to maintain its course. Natural objects don't self-correct their trajectories. Comets don't compensate for rotation. Asteroids don't make micro-adjustments to stay on course. The quantum optical analysis revealed something else that had been missed: microscopic variations in the acceleration that correspond exactly to the object's changing orientation relative to the sun. These variations create a pattern that matches theoretical models for advanced light sail technology, the kind that can maintain stability regardless of orientation. Kaku's team found that these micro-adjustments would require what he calls responsive surface geometry, essentially a surface that can adapt its reflective properties dynamically. This is technology we've only begun to imagine in theoretical papers, not something that occurs naturally in space. The precision needed to achieve such trajectory stability while tumbling is beyond our current engineering capabilities. It's as if Oumuamua knew exactly how to interact with solar radiation to maintain its course. This raises a provocative question. Could Oumuamua be equipped with an advanced passive sail system designed to harness radiation pressure from stars? A silent, efficient propulsion technology that allows it to drift purposefully through interstellar space? If you're finding this as mind-blowing as we did, make sure to hit subscribe and the notification bell. We'll be bringing you more revelations about Oumuamua and other cosmic mysteries that mainstream science isn't talking about. A dead zone launch. But what happens next is even crazier than the propulsion anomalies. The origin of Oumuamua raises even more troubling questions. Using the European Space Agency's Gaia spacecraft data, astronomers have now precisely traced Oumuamua's trajectory back to its origin point. The Gaia mission has mapped over 1.8 billion stars with unprecedented precision, creating the most detailed three-dimensional map of our galaxy ever assembled. When scientists ran Oumuamua's trajectory backward through this stellar database, they made a discovery that defies conventional astrophysics. The object came from what astronomers call the local standard of rest, but specifically from a particular region within it that's eerily devoid of the cosmic mechanisms needed to naturally eject objects at interstellar speeds. Here's why this is significant. Natural interstellar objects should originate from regions with strong gravitational dynamics. Binary star systems, where two stars orbit each other, can eject comets and asteroids through complex gravitational interactions. Massive stars can blast material outward through powerful stellar winds or supernova explosions. But Oumuamua's origin point has none of these ejection mechanisms. The new analysis confirms there are no binary star systems within 10 light-years of its origin point. No massive stars that could generate the necessary ejection velocity. No recent supernova events in that region. No star cluster with the gravitational dynamics needed to accelerate an object to interstellar speeds. This region is essentially a gravitational dead zone, a quiet neighborhood of space where objects should remain relatively undisturbed. There's simply no known natural mechanism that could have accelerated Oumuamua to the velocity needed to escape its home system and travel to ours. The ESA data is clear. This object came from the one place in our stellar neighborhood where it shouldn't have been able to leave on its own. It's as if Oumuamua was placed in this quiet region deliberately, where its launch would attract minimal attention, waiting to drift through space until it reached our solar system. This adds significant weight to the theory that Oumuamua may have been launched deliberately. If you wanted to send an object through interstellar space without drawing attention to its point of origin, you would choose exactly this kind of stellar dead zone, a region where no natural ejection events would be expected. What do you think? Let us know in the comments below what you believe Oumuamua's true origin might be. And if you want to stay updated on this developing story, make sure to subscribe and hit the notification bell. AI reveals a patterned spin, but the most unsettling discovery might be what we've learned about Oumuamua's rotation. What initially appeared to be random tumbling now reveals something far more calculated. In March 2025, researchers applied advanced deep learning algorithms to reanalyze the complete dataset of Oumuamua's brightness variations. These variations, which change by a factor of 10 every 7.3 hours, were previously thought to indicate a chaotic tumbling motion, typical for an irregularly shaped object drifting through space. The new AI analysis tells a different story. The deep learning system, designed to detect patterns too subtle for human observation, identified something remarkable. Oumuamua's rotation follows a complex but predictable mathematical sequence. This isn't the random tumbling we'd expect from a natural object. Instead, it's a deliberate, programmed pattern. Here's what the data specifically shows. First, the primary rotation cycle maintains a precise 7.3-hour period, with variance of less than 0.002%, a level of consistency virtually impossible for a natural object traveling through space for thousands of years. Second, superimposed on this main rotation are micro-rotational adjustments that occur at regular, 43.8-minute intervals. These smaller rotational shifts appear to systematically expose different surface areas to solar radiation. Third, and most telling, is that these rotational patterns create a scanning motion, as if methodically surveying its surroundings as it passed through our solar system. When engineers analyzed this rotation pattern, they recognized something familiar. It matches theoretical models for optimal energy collection. In spacecraft design, controlled rotation is often used to ensure even temperature distribution and maximum solar panel exposure. Oumuamua's rotation cycle would be ideal for an object designed to harvest stellar energy as it travels between star systems. This patterned spin would serve multiple functions for an artificial probe. Energy harvesting from stellar radiation, systematic scanning of surrounding space, signal broadcasting in multiple directions, thermal regulation to prevent overheating on the sun-facing side. If confirmed, this opens up the possibility that Oumuamua wasn't just drifting. It was actively calibrating itself as it passed through our solar system, potentially harvesting energy, relaying data, or even scanning Earth and our neighboring planets. What makes this finding particularly significant is that the pattern wasn't obvious in initial observations. It only became apparent through sophisticated AI analysis of the complete dataset, suggesting an intention to appear random while following a precise program. The implications are clear. If Oumuamua is following a programmed rotation cycle, it's not just a piece of interstellar debris. It's something that was designed with purpose.